Hello and welcome to this new session of the HashiCorp Terraform Certified Associate Exam. So, my name is Alok Kumar and today we are going to discuss another 5 questions that is related with the Terraform Associate Exam. So, this is the question number 16. You are configuring a virtual private cloud VPC in AWS using Terraform. What is the primary purpose of VPC, virtual private cloud? So if you are familiar with the AWS, you also know what is the main purpose of the virtual private cloud. Okay, so the options are to manage database. So this is wrong. Why? Because VPC can host database, okay, but the primary purpose of the VPC is network isolation, not the database management. So the next option is to isolate and control network access for resources. This is true. Why? The primary purpose of VPC is to provide isolated network within a cloud environment. This will allow user to securely launch and manage cloud resources such as virtual machine, EC2 instance in AWS, database and containers. There are many key objectives you can say for the VPC. One is we already discussed the isolations. Other is the customer network configurations, where we can define your own IP range, subnet, route table and gateways. You can also control traffic using the VPC. You can use the security groups, NACL and routing policies to control the inbound and outbound traffics. Okay, internet and private connectivities, public subnet for internet facing services and private subnet for internal services, okay, like database. You can manage all those things, but this question is only about the primary purpose of the VPC and we have to answer as per our options. So these are the details objectives that I provided you. So to provision the serverless application, this is not the VPC is going to handle. You can use the serverless and typically leverage service like AWS Lambda in the AWS to manage container orchestration. This is also not the main purpose of the VPC. Container orchestration that involves service like AWS ECS, okay, AWS ECS and KATS, managed Kubernetes cluster. Okay, so these are to manage the orchestrations. The container orchestrations is not the primary function for the VPC. So this is the correct answer. For the reference link I am going to provide in the description, so you can go through this one, the resource VPC. Okay, here you can find how we can create a resource, how can we define the CIDR blocks. So I am going to provide this link in the description for this question. Okay, so you can go through all the details and you can know how we can create the VPC using the Terraform. Now jumping to the other question. So this is question number 17. You have been working on a Terraform project and have deployed various AWS resources using the Terraform scripts. Where does the Terraform store the state of these resources by default? So while writing the Terraform scripts, you create several types of resources and the Terraform manages the current state in the state file. So Terraform, every time you run it, so whatever is the current one, that is stored in the state file. From there the Terraform will match what is your current expectation and what we already have in the environment. On the that basis they will create either the new instance or delete the existing one, whatever it is, okay, or update the existing one. So what is the default? Okay, so where does the Terraform store the state of these resources by default? On the Terraform cloud platform? No. Terraform cloud can be used for remote state management, but it's not the default store locations. So this option is not correct. In an EC2 instance, Terraform state not stored within the EC2 instance. It managed locally or remotely based on the configurations. So this is also not correct. In an S3 bucket, Terraform can be configured to store the state remotely in the S3 bucket, but this is also not the default behavior. So question is asking about the default, okay, so that you didn't configure anything in the environment, you just run it for the first time and where the state file is stored. So this is also not correct. Locally on the machine where Terraform commands executed, this is correct. Okay, so by default Terraform store the state file locally on the machine where the Terraform commands are executed. So this is the default nature of the Terraform. If you want to refer the state behavior, if you want to dig more on the state of the Terraform, you can refer this link from the HashiCorp documents. So I am going to provide this in the description for this question. You can have a look to have a better understanding on the state functionality. Okay, so now jumping to the next question. Question number 18. What defines the default characteristic of the local backend in Terraform? So if you are not familiar what is the local backend, so the local backend stores the Terraform state file on your local disk without remote locking, collaboration or versioning. It's simple and best suited for individual or small team development, not for the production environment. Okay, whenever your team is small, you can use it. So the local backend in your local disk is stored as a terraform.tf state. Okay, so the option number, automatic encryption of state file in transit, this is not correct. Why? The default local backend does not automatically encrypt a state file in transit. Okay, so this is the wrong. Synchronization of state across multiple Terraform runs. Okay, so the default local backend does not synchronize the state across multiple runs. It operates within a single local context and does not involve synchronization between different Terraform executions. So this is also wrong. Integrations with remote version control system. The default local backend does not inherently integrates with remote version control system. So this is also not correct. Store the state file on your local file system, which I already mentioned just a few minutes back, that it stores of a state file on your local file system. It's a simple and the best suited for individuals and for the small team development. Okay, so A is the correct option. Okay, you can refer the documentations for more detail on this. Okay, now jumping to the another question. Question number 19. In the given Terraform configurations, what sequence will be followed for the creation of the resources? So you know that the Terraform typically follow a sequence based on the dependency. So if you see the AWS instance, it have the AMI and instance type. So it is not dependent on any of the other resources. But if you see the AWS EIP, okay, the local name is web server IP, VPC is true, but it's using the instance type which is created above. So AWS instance web server, this web server coming from this, okay, and the ID of that web server. So Terraform configurations needs to be in a sequence. So we have to follow this principle, which is the dependent will go below and which is not dependent will go above for the resource creations. Okay, so if we see the options D, both resources are created simultaneously. So this is not a case of parallel executions. So this option is wrong. Why? Because Terraform typically follow a sequence based on dependency. Okay, so elastic IP is dependent on the web instance, web server. So it should be created first because it's using the ID of that web server. Okay, so we cannot execute as a parallel. The parallel execution is not possible. This is possible when the both resources is not dependent on each other. Okay, then only we can execute the parallel executions. AWS EIP followed by AWS instance. AWS instance creation is not dependent on any other resources. This is dependent. So this will be created when AWS instance is created. So this is also wrong. Vice versa is not possible in this case. Creation order cannot be determined from the provided configurations. So option B is also wrong. Why? In Terraform, the resource creations order is usually determined based on the dependency declaration in the configuration. Okay, so AWS instance followed by AWS EIP. So whatever is the configuration is correct. So AWS instance followed by the EIP. First we create this one and then this one, because second one is dependent on the first one. For more reference, you can follow this link for the create resource dependency, so that you can get the overall idea how the Terraform will work. Okay, so now jumping to the next question. Question number 20. Choose the response that fill in the blanks in the following statement. Terraform Cloud can be managed from CLI but requires which of the option? So we can manage the Terraform Cloud through the CLI, but what options it's required before using it? So manual synchronizations with local state file. We know that Terraform CLI allow management of Terraform configuration and state. The necessity to manually synchronize local state file is not a requirement for managing Terraform Cloud from the CLI. Authentication from API tokens suffix for CLI interactions with the Terraform Cloud. So this is not correct. Installations of additional plugins. We don't have any plugins, or you can say the Terraform not support. The Terraform CLI typically includes functionality to interact with the Terraform Cloud without additional plugin installations. So managing the Terraform Cloud from the CLI does not require the installation of extra plugins. So this is also wrong. Paid subscription. Okay, so the ability to manage the Terraform Cloud from CLI does not inherently require a paid subscriptions. Okay, so while certain features or usage limit might be tied to the subscription tier, okay, but for general activity it's not required to take a paid subscription. So this is also wrong to use the AWS Terraform Cloud from the CLI. API token authentications, this is correct. Terraform Clouds can indeed be managed from the command line interface, that is CLI, using the Terraform CLI tools. However, for accessing and interacting with Terraform cloud features from the CLI, authentications via an API token is necessary to ensure secure access to the Terraform cloud resources. So this is the correct options for this question. Hope you like my video. Hope you like my effort that I am putting. Okay, if you didn't subscribe my channel, yes, please to subscribe it. It always motivate me to bring a new videos. Okay, and there are several videos that is currently in the pipeline for this Terraform associate exam. Have a nice day and keep learning. Thank you.